Hello everyone, welcome to Sangeeta Sirsa channel. In last video, we have seen the structure of procedure-oriented programming, the limitation of it, and the structure of object-oriented programming. Today, we will learn about some of the basic concepts of OOP. So let's get started. So the concepts of OOP includes classes, objects, data abstraction and encapsulation, inheritance, polymorphism, dynamic binding, and message passing. So the first one is a class. So a class is nothing but a blueprint, or you can say it is a template which is used to create object of a class. And without class, we cannot create the object. Without object, we cannot call the methods or functions of the class. So we say a class is nothing but a blueprint. As you can see in this particular image, this is a blueprint, or you can say a design or a template for building up of this Bangalore. If blueprint is not there, we cannot build this object. So it is mandatory to have a class so that we can create object, and class is a way to keep the data and functions together into a single unit. And we say class is a user defined data type. User defined data type in the sense means the name of class is not predefined. It is according to the requirement which name of class we need to implement. For example, I need to write a program for class student, or if I need to write a program for class bank. So these two classes, bank and student, these names are not predefined. They are user defined. So that's why we call class as user defined data type. Example, so we have a class animal which contains of private and public members. Animal 1, 2 and 3 are nothing but the object of class animal. The second concept is an object. An object is a basic runtime entity of object-oriented system. Runtime entity. So when we talk about runtime entity, that means during runtime we use the object of the class to call the member function of that particular class. So we all know compile time and runtime. What is the use of compile time? When we actually write the code, the next step is we need to compile it. So that is what a compile time is. During compile time, the compiler will check for any syntactical errors, not for any logical errors. Syntactical errors are nothing but semicolon missing, curly brace not closed. So all these errors we get to know during compile time. What about runtime? Runtimes will either give you logical errors or it will give you a proper output. So in object oriented programming, when I need an output, that means when I need to call the member function of the class, we don't simply write the name of the member function. We have to create object with the class name. After creating object, I need to call the methods of the class. Object name, dot operator and the methods. So when I am writing this code and when I am executing it, so during runtime, this object only helps the member functions to get executed. So that's why object is called as runtime entity. So an object will have a data, a method associated with its own. Each object will have a data and a method. Each object will have some unique identity. the state, and the behavior. Take an example of this class, motorcycle. Motorcycle is the class. The objects will be off-road motorcycles, sports bike, touring or cruiser motorcycles. So this becomes the object of this class, motorcycle. So in the next example, you can see this car. The car is an object which has some states, some behavior. Take a look at this. Object properties and methods. So if I have a class student, I have the properties, or you can say the attributes of class student. So you can say this student is a user defined type. It is not already predefined. It is not already there. According to the requirement of a program, I am defining a class with the name student, with the name teacher, and with the name exam. So the class is a user defined data type. So when we are talking about the object properties, we have the properties and, or you can say, attributes of student: first name, last name, social second number, class standard, email, and some methods. Methods are nothing but the functions of the class: read book, give exam, calculate. Same for class teacher. We have some set of properties, some set of methods or functions. We have a class exam with some set of properties and with set of functions. So an object is a runtime entity which is useful for executing the member functions of the class. Next is encapsulation. Encapsulation is nothing but the binding of data methods together into a single, right? So we all know a capsule, the medicine consists of so many ingredients, right? So many ingredients are binded together in a particular capsule. Okay, so that capsule we call it as a class which has some set of methods and which has some set of variables inside it. So together method plus variable will give you a class. So the process of doing that binding, of keeping the data and method together, is called as encapsulation. So when I am binding the data together inside a particular class, it helps us to hide the data. It helps us to maintain the integrity of the data. It enhances the data hiding. So with the help of this sensitive data, we can hide from the user, as because we are keeping the data and methods together into a single unit. That particular process is called as encapsulation. Next is data abstraction. So data abstraction refers to the act of representing essential features without including the background details. What does this mean? Take an example. I am standing at the billing counter of a supermarket. What is the job of that billing counter person? He will simply just scan the product, get the bill done, and collect the cash. That particular person will just do his or her job, but that person is not willing to know about the background details. Background details in the sense, the UI, the user interface on which the billing counter system person is working on. He is just interested in the UI. He is not interested in knowing what are the background details, like which program or which technology is being used for developing this application. So data abstraction is, we are hiding the background details and showing the essential features. As you can see in this image, the image of a car, we are hiding unnecessary things and showing the necessary things, that is the body, the color of the body, and we are hiding the unnecessary parts, that is nothing but abstraction. The second example, as you can see, what we see, we have a brake, an accelerator in a car, that are the essential features, but how it is working, what is the mechanism behind it. So as a driver, I will not be so interested to know all these things, right? So that's why it is in the background. So data abstraction is hiding the background details and showing the essential features. Next is inheritance. Inheritance is nothing but deriving a new class from an already existing class. Take a normal general example: parent 1, parent 2, mom, dad, and we have a class child. So, child may have some of the features of dad, the child will have some of the feature of his mom. So, the child class becomes the derived class, mom, dad becomes the base class, the old class. So when we are deriving a new class from an already existing class is known as inheritance. So the main advantage of using inheritance is code reusability. Code reusability is nothing but if the code is already implemented, we cannot we cannot write the same code again. If it is there, we will simply reuse it in some different class. So that reusing of a code is one of the main advantage of inheritance. Take an example. So we see in this image class fruit, with from this fruit class I have derived new classes apple, banana and guava. So the old class is a base class, new class is a derived class. So derived class will inherit some of the features from base class, some or all the features of base class. So it leads to code reusability. I'm using the code of base class which is already implemented into derived class. That is what code reusability is. Next is polymorphism. Polymorphism means the ability to take more than one form. Ability to take more than one form. Take an example in this image. In this image, I have a class shape, I have a method draw, and some derived classes circle, triangle, and square. I have draw function in each and every class. So when I'm using this draw function, draw circle, this draw function will help me to draw triangle. This draw function will help me to draw square. So one draw function is taking how many forms? Three forms: for drawing circle, for drawing triangle, and for drawing square. That is what polymorphism is. Polymorphism is the ability to take more than one form, and it will exhibit different behavior, right? Different behavior means this draw function is exhibiting different behavior for drawing a circle. This draw function is exhibiting different behavior for drawing a rectangle. This draw function is exhibiting different behavior for drawing the square. Next is dynamic binding. Binding. What is the basic meaning of binding? The basic meaning of binding is nothing but the process of linking the function call to the code to be executed in response to that call. a int. So this is the function definition. I need to call calling that particular function where I have defined that function. So the linking of function call to be executed is nothing but binding. If this binding taking place, it is called as dynamic binding. During runtime means when we are actually executing that code, the function call will get linked to the function definition during runtime. So that is why it is called as dynamic binding. Linking of code to be executed in response to the particular function when it is done at runtime, it is called as dynamic binding. Next is message passing. Message passing is the concept where the object communicate via message, not really a message, but the communication takes place when an object requests to execute a member function of a class. The steps involved in this message passing is first we need to create classes. After creating classes, create objects, establish communication among objects. Objects communicate with one another by sending and receiving information. So a message for an object is a request for execution of a procedure. Suppose I have a class student. I have a function void input. Object of that class s dot input. So this s dot input executing input function dot input. This becomes the message to invoke this function input. S dot input. We are requesting an object for the execution of the procedure. So this is nothing but message passing. Thank you.